Welcome to the 82nd lecture of Digital Electronics. So in lecture number 81 we have introduced you about what is flip-flop or what is gated latches. So in gated latches, along with the latch you should have an enabled input. So in this lecture we will be dealing with two types of gated latches. The first one is gated SR latch, or I can say that it is SR flip-flop, and second one is gated D latch, that is D flip-flop. Okay, we will deal with these two in this lecture. Okay. Now coming in the first one, that is gated SR latch. Okay. Coming into gated SR latch. Gated SR latch, or what you can say it as SR flip-flop. Okay. Now if I am drawing the latch part, okay, I have one input here. There is a NAND gate. Here you will get Q. Another input coming in. Here there is a NAND gate. Sorry, draw it once more. Another input coming in. There is a NAND gate. You will get Q bar, and this Q is fed back here, and Q bar is fed back to here. So this is basically a latch. Now here you should have set and reset, say S1 and R1. Now if you are looking here, you should get S1. You should enable this S1 and R1 based on some enabled input. Okay, so now I am going to give this enable input. So I am having S here, giving a NAND gate. This is I am giving it to S1. R here, giving a NAND gate, I am giving to R1, and along with that I am giving an enable input. I am giving to both these gates. Okay. Now I am going to write the expression for S1 and R1. Okay. Now what is S1? S1 is say this is G1, G2, G3, G4. Okay. Or what you can write in another way. I will do it in this way. We will create a table. Gate, the corresponding output. Okay. So gate G1, the corresponding output of the gate G1 is S1, and S1 is given by S dot enable the whole bar. S dot enable the whole bar. Okay. For gate 2, what is it? Output is R1. What is R1? R1 is R dot enable the whole bar. What is G3? The output of G3 is Q. What is Q? Q is basically S1 dot Q bar the whole bar. S1 dot Q bar the whole bar. Now what is the output of gate 4? That is Q bar. This Q bar. Q bar is basically R1 dot Q the whole bar. Okay. Now I am going to play with these things. Now see, now if I am looking into the expressions, suppose I am making enable as 0. When enable is equal to 0, what is S1? When enable is 0, S1 is S dot 0 the whole bar. What is it? That is 0 bar. That is 1. Again, what is R1? R1 is R dot 0 the whole bar. What is it? That is again 0 bar. That is equal to 1. That means here S1 and R1 is equal to 1. When enable is equal to 0, you can see that S1 and R1 is equal to 1. Okay. Now if that is the case, what is Q and Q bar? Okay. Or what is the output of gate 3? In this case, what is the output of gate 3? That is the question. That is S1 1 dot Q bar the whole bar. What is it? That is Q itself. That is Q bar bar. That is Q itself. And what is the output of gate 4? Output of gate 4 is, what is output of gate 4? What is R1? R1 is 1. 1 dot Q the whole bar. What is it? That is Q bar. That means when enable is 0, whatever is the state of the system, it will remain there. Okay. So there is no change of state. There is no change of state. There is no change of state. Okay. No change of state. That means whatever is coming in, you will get Q or Q bar. It is if enable is 0, nothing will happen. Whatever is the present state, it will, whatever is the state, when Q is equal to 1 or Q bar is equal to 0, or when Q is equal to 0 or Q bar is equal to 1, it will remain there. That is the first case. Now if you are coming into this one, next case, that is when enable is equal to 0. There is no change. Now I will go for this enable is equal to 1 also. Okay. Yeah, there is no change. That is when enable is equal to 0, there is no change. Okay. Now we will take one more case with enable is equal to 0, and taking enable is equal to 0 and keeping enable is equal to 0, and I am keeping here what happens, this is S0 is equal to 1 and R0 is equal to 1. Okay. Now see, here one more inference we can take. Whatever is the value of S or whatever is the value of R, when enable is equal to 0, whatever is the value of S and whatever is the value of R, you will get S1 and R1 is equal to 1 only. That means here S and R are here the output is not dependent on S and R. What we can say, here the output is not dependent on, if enable is equal to 0, the output, that is Q or Q bar, is not dependent on S and R. Okay. That means there is no change of state. Now I am going to take next thing. I am going to make this enable is equal to 1. Okay. So let me write that expressions once more here. Yeah. That is here. I am going to make enable is equal to 1. When enable is equal to 1, there are I can have S is equal to 1 and R is equal to 0. First case. Then second case. So here what happens? Second case, when S is equal to 0, R is equal to 1. Second case. Third case, S is equal to 1, R is equal to 1. Last case, S is equal to 0 and R is equal to 0. Okay. That is for enable is equal to 1, you have these 4 cases. Okay. Now, if coming to the first case, what is the output of G1? That is S1. Okay, so I am writing here. I am writing like this. So you will get G1, output of G2, output of G3, and output of G4. Okay. Now, what is G1? G1 is, or output of G1 is basically S1. What is S1? S1 is basically, I can write it as S dot enable the whole bar. It is S dot enable the whole bar. Now what is output of G2? G2 is S2. That is S2 is equal to R dot enable the whole bar. R dot enable the whole bar. What is G3? Output of G3. Output of G3 is sorry, it is not S2, it is R1. It is R1. Okay. What is output of G3? Output of G3 is S1 dot Q bar the whole bar. That is S1 dot Q bar the whole bar. And what is output of G4? G4 is R dot Q, R1 dot Q the whole bar. Okay. Now coming into G1. Here what happens? S dot enable the whole bar. Okay, what is it? 1.1 the whole bar. What is it? That is, so 1 bar, that is equal to 0. Okay, that is output of gate 1. Now what is output of gate 2? Gate 2 is R dot enable the whole bar. 0.1 the whole bar. What is it? 0 bar, that is 1. What is gate 3? S1 dot S1. S1 is, okay, I know this is S1 and this is R1. Yes, so this is S1, we can write as S1. This is R1. Okay. Now S1 dot Q for S1 dot Q bar the whole bar. That is 0 dot Q bar the whole bar. What is it? That is 0 bar. That is 1. Now what is output of gate for R1 dot Q? What is R1? That is 1 dot Q the whole bar. What is it? That is Q bar. So since this is Q, you can take Q bar as 0. That means the output will be set to 1. So the output will be set to 1. So that is, this is basically a set logic. Now coming into S is equal to 0 and R is equal to 1. When S is equal to 0 and R is equal to 1, what is S1? S1 is equal to S dot enable the whole bar. That is 0 dot 1 the whole bar. Okay, right? 0 dot 1 the whole bar. That is 0 bar, that is 1. Now what is the output of gate 2? That is R1. What is R1 here? R1 is R dot enable the whole bar. That is R is 1 dot 1 the whole bar. 1 dot 1 the whole bar. That is 0. Now what is the output of gate 3? S1 dot Q bar the whole bar. That is 1 dot Q bar the whole bar. What is it? That is Q bar bar. That is equal to Q. Now again, what is the output of gate for R1 dot Q? What is that? Is it? That is 0 dot Q the whole bar. So what is it? That is 0 bar. 0 dot Q is 0 bar. That is 1. That means that is basically Q bar. Q bar is equal to 1 means you will get Q is equal to 0. Q bar is equal to 1 means you will get Q is equal to 0. What is it? That is basically a reset state or clear state. It is clear or reset. We can write it as reset. Clear or reset. And next case, S is equal to 1, S is equal to 1 and R is equal to 1. That is the question. Okay. Now when S is equal to 1 and R is equal to 1, what is S1? S1 is 1 dot 1 the whole bar. What is it? That is 0. What is R1? R1 is R dot enable. That is 1 dot 1 the whole bar. That is equal to 0. Now coming to gate 3. That is for gate 3 the output is S1 dot Q bar the whole bar. What is S1? What is S1? 0 dot Q bar the whole bar. What is it? That is 0 bar. That is equal to 1. Again, what is gate for R1 dot Q whole bar? That is what is R1? R1 is 0 dot Q the whole bar. That is again 0 bar. That is equal to 1. So here we can say that this is equal to Q and this is Q bar. So both are equal to 1. So what we can say? It is invalid state. It is basically an invalid state. When S is equal to 1 and R is equal to 1, it is invalid state. Now next case is when S is equal to 0 and R is equal to 0. That is the last case. So here what is S1? Here what is S1? In the case of S1, S dot enable the whole bar. That is 0 dot 1 the whole bar. 0 dot 1 the whole bar. That is it. That is 0 bar. That is 1. Now what is R1? R1 that is equal to R dot enable. That is 0 dot 1 the whole bar. 0 dot 1 the whole bar. That is equal to 0 bar. That is again equal to 1. For gate 3, what is the output? S1 dot Q bar the whole bar. What is it? That is 1 dot Q bar the whole bar. What is it? That is Q bar bar. That is equal to Q itself. Again for gate 4, R1 dot Q. What is R1? 1 dot Q the whole bar. What is it? That is Q bar. That means you will get the output as Q and Q bar only. That means whatever is the present state, you will get it as the state itself. That is no change. There is no change. Okay. Now coming into a simplified form of this, coming into a simplified truth table of SR flip-flop, coming into a simplified truth table of SR flip-flop. So here I am having enable S R present state and next state, present state and next state, and what is the condition? Present state and next state, and what is the state? This is state. So initially I am keeping enable is equal to 1 only. So present state I am having for 1, 2, 3. So it is 0, 0, 1, 0, 1, 0, 1, 0, 1. So enable here it is 1, 1, 1, 1, and the last state it is 0. Now coming to the first case, that is what is values of S and R, that is S equal to 1 and R is equal to 0. This is the first case. S is equal to 1 and R is equal to 0. S is equal to 1 and R is equal to 0. So what do you get? You will always get output as 1. The state is 1. Okay. So this basically set. Now next case, that is when S is equal to 0 and R is equal to 1. S is equal to 0 and R is equal to 1. Present state is there, and what is in a state? That is always in a state will be equal to Q is equal to 0. That is next state will be 0. That is a reset. It is reset, or it is also known as clear. Now coming into next case, that is when S is equal to 1 and R is equal to 1. Equal to 1, R is equal to 1 in these two cases. When S is equal to 1 and R is equal to 1, you don't know what is in a state. Okay, you don't know what is in a state because it is invalid state. It is invalid, or we can term it as intermediate state. Intermediate state. Now last case, when S is equal to 0 and R is equal to 0. S is equal to 0 and R is equal to 0. There is no change. That is present state and present state will be equal to next state. So that is no change. Now when enable is equal to 0, what happens? That is when enable is equal to 0, what happens? That is whatever is the value of S and R, there is no change of state. Whatever is the value of S and R, that means S and R. So here I am having present state as 0 and 1. Whatever is the value of S and R, it will remain there. So here also you have no change. Also you have no change. Okay. So that is the basic truth table of SR flip-flop. Okay. Hope you have understood the formation of gated SR latch. Okay. So first part, that is gated SR latch is over. Okay. So for gated SR latch, along with the latch, you have this enable input. So you have 4 NAND gates: G1, G2, G3, G4. So I have given the outputs of G1, G2, G3, and G4, and given when first case, and given the first case when enable is equal to 0, whatever is the value of S and whatever is the value of R, you will get 1. That means whatever is the value of S and whatever is the value of R, you will get S1 and R1 is equal to 1. That means output of gate 3 and output of gate 4 will remain as Q and Q bar. That means there is no change of state. That is when enable is equal to 0. And after that I have done with the analysis of when enable is equal to 1, S is equal to 1, or R is equal to 0, that case. S is equal to 0, R is equal to 1, that case. S is equal to 1, R is equal to 1, that case. And S is equal to 0, R is equal to 0, that is. So there we have got 4 cases. That is set, clear, invalid, and no change. And I have simplified it into truth table form. Okay. Now if you are taking into the logic symbol of this SR latch, you can draw like this. That's a logic symbol for having S and R as input along with the enable, and here I am having Q and Q bar. Okay. So this is the logic symbol of this SR latch. Hope you have understood the formation of this SR latch. Now coming into next one is D latch or gated D latch. Okay, I am going to explain about gated D latch. coming into gated D latch. In the case of D latch, what is the only difference? S is equal to R bar, or we can write it as, or we can write R is equal to S bar. In these two cases, both are same. Okay, that means if you are looking into the gated SR latch, if one input is the complement of other, then we can term it as D latch. This D latch is also known as D. The full form is delay latch or delay flip-flop. D latch or delay gated delay latch. Gated delay latch is known as D flip-flop. Gated delay latch is known as D flip-flop. Now coming into this in detail explanation of this gated delay latch or D flip-flop. Gated delay latch is also known as D flip-flop. Okay. Again, our this one is there. Latch is there. First you form the latch Q bar. One input is coming here. Other input is coming here. We are having a latch here. So this latches, and another two NAND gates coming in. This is D. You are having only one input, that is D, and for the second one it is becoming D bar. You will get D bar, and one enable is there, and enable is going into these two. The enable is going into these two. Okay. Now I am making this as S1 and R1, because on the right side it is basically SR latch, so I am making it as S1 and R1. Now what is the expression for now? Keeping this as gate 1, gate 2, gate 3, gate 4. Now let me come into the basic expressions of these gates. So drawing the truth table, having gate, the corresponding expression. Okay. So I am going to deal with first G1, gate G1. So what is S1? S1 you will get it as D dot enable the whole bar. D dot enable the whole bar. For gate 2, what is the expression? R1. What is R1? R1 is equal to D bar dot enable the whole bar. And what is the output of gate 3? Output of gate 3 is S1 dot Q bar the whole bar. And the output of gate 4. What is the output of gate 4? That is R1 dot Q the whole bar. R1 dot Q the whole bar. Okay. Now I am going to make enable is equal to 0. That is my first case. First case I am going to make enable is equal to 0. When enable is equal to 0, what is okay? Now when enable is equal to 0, what is S1? S1 is D dot 0 the whole bar. What is it? That is 0 bar. That is equal to 1. Now what is R1? R1 is D bar dot 0 the whole bar. What is it? That is 0 bar. That is equal to 1. So that means S1 and R1 is equal to 1. That means what is the output of gate 3? What is the output of gate 3? 1 dot Q bar the whole bar. What is it? That is Q itself. And what is the output of gate 4? That is 1 dot Q the whole bar. That is Q bar. That means there is no change. There is no change. That means whatever comes as input or whatever comes in D, there is no effect on output. Okay, that is there is no change in the present state and next state. Now coming into next case. I am going to make enable. Now I am going to make a very big table. Okay. Make a big table. So enable I am making it as 1. In all this case I am making enable is equal to 1. Here enable is equal to 1. Enable is equal. There are 4 cases. Enable is equal to 1. Okay. Now do it here also. Okay, we'll do it in another. Yeah, we'll keep it in this way. Always enable is equal to 1. Okay, when enable is equal to 1, S is there, R is there. Sorry, not there is no S and R, right? There is only D. I'm going to make enable is equal to 1. Okay, and I'm having D. D is there. Then what is the output of gate 1 or G1? G2, G3, and I am having G4. Okay. For G1, what is the expression? For G1, D dot enable bar. For G1, it is D dot enable the whole bar. For G2, the expression is D bar dot enable the whole bar. This is S1. R1 is D bar, right? D bar dot enable the whole bar. And what is output of G3? Output of G3 is S1 dot Q bar the whole bar, S1 dot Q bar the whole bar, and the output of G4 is R1 dot Q the whole bar. Okay. So here I am going to make D is equal to 0 and 1. Okay. There are 2 cases here. Okay. Now I am going to make D is equal to 0 and D is equal to 1. There is only 2 cases. D is equal to 0 and D is equal to 1. Now when D is equal to 0, what happens? When D is equal to 0, what is the output of gate 1? When D is equal to 0, output of gate 1 is enable is equal to 1. That is 0 dot 1 the whole bar. That is 0 bar. That is equal to 1. So that is equal to S1. What is the output of gate 2? R1. That is equal to D bar. D bar is 1 dot enable bar. 1 dot 1 the whole bar. That is 0. Okay. So you got R1 as 0. So what is the output of gate 3? That is S1. That is 1 dot Q bar. 1 dot Q bar the whole bar. What is it? That is Q. And here what happens? R1. That is 0 dot Q the whole bar. What is it? That is 0 dot Q is 0 bar. That is 1. That is Q bar becomes 1. So Q becomes 0. That means this is basically what? So this is basically a reset. When D is equal to 0, what happens? The next state becomes 0. So that is basically, this is basically reset state. Basically reset. Next case, when D is equal to 1, what happens? That is the next question. When D is equal to 1, what happens? First case, the output of G1, that is S1. S1 will be equal to 1 dot enable, that is 1 dot 1 the whole bar. What is it? That is equal to 0. Now what is R1? R1 is D bar, that is 0 dot 1 the whole bar. That is 0 bar, that is equal to 1. Now coming to G3, that is S1 dot Q bar, that is 0 dot Q bar the whole bar. That is 0 bar, that is equal to 1. That is basically Q. Now coming into G4, that is R1, that is 1 dot q the whole bar. What is it? That is equal to q bar. Okay. Now since q is equal to 1, q bar becomes 0. Say q is equal to 1, q bar becomes 0. So what happens? When d is equal to 1, it will remain there. Or we can write it as q is equal to 1. Q is equal to 1 means it is set. Q is equal to 1 means it is set. Okay. Now coming into the most simplified form of the truth table of D flip flop. Simplified form. Truth table of D flip flop. Okay. So here I am having enable D present state next state. PS stands for present state and NS stands for next state. Okay. And what is the state? Okay. Now when enable is equal to 1, first case is enable is equal to 1, D is equal to 0. And second case is enable is equal to 1 and D is equal to 1. Last case is enable is equal to 0. Enable is equal to 0, whatever is D, no problem. Now there are present state as 0 and 1. Now when D is equal to 0, what happens? It is basically a reset. Reset means next state becomes 0. It is basically reset. That means next state becomes 0. So it's basically a reset. Now when enable is equal to 1 and D is equal to 1, D is equal to 1 means it is basically set. That means if present state is 0 and 1, it will be set to 1. That is, it is set. Okay. Now coming into last case, that is when enable is equal to 0. When enable is equal to 0, what happens? There is no change. Enable is equal to 0 means whatever is the present state or whatever is D, present state becomes equal to next state. That is, there is no change. There is no change. Okay. So that is a truth table of D flip flop. Okay. So I think you have got an you have got an idea about this SR flip flop. Okay. So here I have mentioned about gated SR flip flop and gated SR latch and gated D latch, or SR flip flop and D flip flop. Okay. So I have drawn the logic diagram of this gated SR latch and given the third input. What is the third input along for this SR latch? The third input for this SR latch is this enable. Okay. So based on this enable already, what happens to the present state and next state? That is already dealt here. Now the truth table of SR flip flop I have drawn in a very simple pattern. That is again deriving from here. Now coming into gated D latch, S is equal to R bar or S is equal to S bar, and we have drawn the basic logic diagram of a D flip flop and derived the expressions for this D flip flop. Okay, and the truth table is formed, and the corresponding truth table we will get reset, set, and no change. In SR flip flop also you will get these cases, right? That is set, reset, invalid state, no change, and there is no change as well as invalid state. Hope you have understood the formation of this gated latch and gated D latch. Okay. So thank you, and in the next lecture we will be dealing with some elements of this edge triggering, and after that we will deal with edge triggering, and after that we will go with JK flip flop. Okay, thank you.